Greetings, math fans. All right, so this is day 3, and it's a note sheet, so make sure you grab it out of the Google Drive. But today's topic is called parametric equations, and this is actually a new topic for you guys. And we're going to be using this in calculus, and not for a few chapters here, but you will see this. And it's not too difficult. It's basically introducing a new variable, which is going to be kind of cool. And we're going to see some better applications in the next couple of days. So I'll show you. It'll actually be on day 5 where you see a really good application of it, but you have to learn some of the basics, okay? So basically, just to kind of look at the note sheet here, it's a relation. Basically, you see a set of ordered pairs, right? Your x, y. And a parametric equation is your third variable. We call that t. Okay, a lot of times t is time, okay? But it can be whatever. I'm just going to kind of highlight here a little bit. So like this here. So basically you have x is f of t. So it's going to be in terms of t. So x is going to be f of t and y is going to be g of t. So instead of having an xy function, you're going to have f of t and g of t. So it's like just an additional variable in here. Okay. And these points over an interval of t values will produce a parametric curve. So I'm going to give you, you're basically going to have an x equation, you're going to have a y equation. It's going to be in terms of t, and you're going to be given different values of t. You plug it into the values of t to get an xy coordinate, and then you're going to graph it. It's really pretty easy. Okay. Anyway, these equations with a t are called parametric equations. And so again, parametric equations, this guy right here, they're going to be in terms of x, y, and t. Sometimes it goes a little crazy on me, okay? All right. Okay, so in terms of x, y, and t. And remember, rectangular equations are just in terms of x and y, okay? So let's get right away and do a nice little friendly example here. So basically, I'm going to give you guys, if you notice, x equals, so this guy these things right here. Okay, I'm going to give you 2 equations. And I'm telling you, t is between -4 and 4. So basically what you're doing is you're literally just plugging into the values of t and coming up with an xy coordinate. It's really easy. So let's go ahead and pick some values here. I'm going to pick, we need quite a few of them here. So just, they're easy to come up with, right? So -4, -3, -2, -1, 0, 1, 2, 3, and 4. Okay? So I'm going to, again, not to make this video long here, but, you plug in, right? Absolute value -4 is 4. 4 plus 2 is 6. Absolute value -3 is 3. So I'm just going to actually fill these in here. So it's 6, 5, 4, 3, 2. And then, of course, it comes up again because now absolute value of 1 is still 1. So it goes 3, 4, 5, and 6. Okay, so that's pretty easy. And then the y values, plug those in and you get -3, -2, -1, 0, 1, 2, 3, 4, and 5. So really what you're doing here is this is still your x and y Cartesian coordinate plane. We're just going to plot those values. Okay. So let's go ahead and do that. 1, 2, here I'm going to do it in a different color here so we can see it pretty easily. 1, 2, 3, 4, 5, 6, -3, 5, -2, 4, -1, 3, 0, 2, 1, 3, 2. So it kind of goes back this way, and this way, and this way, and that way. Okay, so that's it. And then go ahead and let's actually graph it now. We just graph the points. Oops, so sorry, I'll make it a little darker here. Okay. All right, so this is our graph. Now, a couple things I'm going to require from you guys. In fact, it even tells you, indicate the direction. So you need to indicate the direction. Okay. Something you need to indicate. And then you need to tell me, it says state the initial and terminal points. So, it's nice on the graphs and also on the chart. So initial and terminal. So initial and terminal. And that's all you really need to do. So initial right there, terminal right there. It's pretty easy, but that's the graph. Really, it's pretty simple, right? Okay, so let's move on here. Okay, so number 2, it gets a little more complicated, and the only reason I say it gets a little more complicated is because you have to, it's a quadratic, right? It's t squared. Okay, but it's no big deal. Okay, same thing, t is in our function here in terms of x and y, but t is greater than or equal to -3. So it's starting at -3 and it's going on to infinity, right? Positive infinity. So let's pick some values here. I'm going to pick -3, -2, -1, 0, 1, 2, 3, 4. And those actually fit pretty well. If you start getting bigger than that, then it gets a little crazy, okay? So again, I'm going to plug these values in just to get through the lesson here pretty fast. It's pretty easy. So you get 10, 8, 6, 4, 2, 0, -2, -4. And then the y values, -1, 4, 7, 8, 7, 4, -1, and -8. Okay, so those are all reasonable values. They all fit on the graph here, which I think is kind of important. Okay, so if I go ahead and plot these, again, remember you're just plotting the x and the y. So 10, -1. Let me plot it in a different color here again. 10, -1 is right here. 8, 4 is right here. 6, 7. 6, 7 is right here. 4, 8. 3, 4, 8 is right here. This is all a 10 by 10 grid here, so it's easy to graph. 2, 7. 0, 4. -2, -1. And -4, -8. So the graph starts here. And this one needs an arrow because it does keep going. Okay, so indicate your direction. Your direction is this way, right? And if you want to, again, label your, this is your initial point. Initial, and it has no terminal point. You guys agree with that? Because, of course, it goes to infinity. It's greater than or equal to -3. Okay, so that's what parametric graph is. Really pretty easy, right? Okay, so now what we're going to do is a little bit more than graphing, because that would be like too easy. Your little brother could do that, plot points, right? All right, so what we're going to do is we're going to convert the parametrize. That's a great word. That'll get you mashed potatoes because you sound super smart. Convert the parametrize, like your mom or dad says during dinner. So what did you learn today? And like, oh, we learned how to parametrize a curve. They'll be like, oh my God, more mashed potatoes and life is good, right? You're getting lots of good food and it's nice. And maybe, so you have like pasta or rice or whatever it is. Okay. Anyway, back to this. Sorry, I digress. Convert the parameterized curve to a Cartesian equation standard form. So basically what it is a parameterized curve is in terms of t, and I want to convert it into something that's just x and y. So that's important. A Cartesian equation is just in terms of x and y, and this is, parameterized is x, y, and t. It's all three of those. I wanted to convert it just to two. So basically what you have is, I just need to do some substitution here. So I just need a little bit of room here. You have the equations above, okay? So I'm going to take that x equals 4 minus 2t, and I'm going to solve for t, because I'm just going to substitute that into the second equation, and then everything's going to be in terms of x and y. It's like super easy. It really is. So if I solve for t, I get negative 2t equals x minus 4, and then divide everything by -2. So t is equal to x minus 4 over -2. Okay, that's pretty easy. And I'm just going to substitute it in for y. So it's y is equal to 8 minus t squared. So here we go. Y is equal to 8 minus x minus 4 over 2 squared. So you notice I solved for x here. I could have solved for y, or used the y equation to solve for t, but then you got a t squared in there. That's ugly, right? Because then you got plus or minus when you take the square root, and it's like you want to. It's kind of like when you do systems of equations. You want to solve for the easiest one first to substitute in. It makes life a little bit easier. Okay, and so anyway, this is it, guys. This is really your answer here. I mean, I don't expect you guys to FOIL it out. It's kind of dumb. It makes it more complicated. Okay. And then what you want to do is, now it's, if you going back to, see how t is between, or t is greater than or equal to -3. Now you got to put that in terms of x. And the reason I say in terms of x and not y is because see how it says x equals 4 minus 2t and y equals 8 minus t squared. And it's basically, you know what the value of t is because it's in terms of t, right? X equals something with t and y equals something with t. Well, if you look at our equation, y is in terms of something with x. So I need to restrict x. That's important. Okay, let's say I happen to solve for x instead, and I had x equals something with y in it, then you need to restrict y. Okay, so I need to restrict x. And that's actually really easy because you just look to see what the value of t is and what the value of x is. Well, t is greater than or equal to -3, so look at x. What happens with x? Well, x, doesn't it start with 10 and it goes down? So x has to be less than or equal to 10. Okay, just look at the value. This is really easy. I mean, or you could literally take that -3 and plug it back into the equation, which is really how you got the x, but recognize that it's going down. That's why if you look at the t chart, you can see, oh, x starts at 10, oh, and it goes down from there. Okay, so you would say x is less than or equal to 10. Okay, and that's your answer. You need this whole thing here, guys. That is parametrizing or converting the parametrized curve to a Cartesian equation in standard form. Okay. All right. And by the way, standard form. We're going to get to another one in a second here. But this is a find is for a quadratic. Standard form for like if you have like an ellipse or a circle, then it's got to be something like x squared plus y squared equals 9, right? In standard form for a circle. Okay, but that's the equation. Okay, cool. So let's do. I got 2 more to do here. Okay, so this one is graph the following parametric. So same thing. We're going to pick some values. Now it's a trig, so. We like trig. We just learned trig. We just got done with our final exam, so you guys better know your trig. And t is between 0 and 2 pi. So we're going to pick some values. We're going to pick 0 and pi over 2, and pi, and 3 pi over 2, and 2 pi. Okay, good values because they give us nice whole numbers, and I don't have to deal with square roots and whatnot. So, all right, so if I do, again, sine of 0 is 0, sine of pi over 2 is 1, 0, -1, and back to 0. And cosine is going to be 1, 0, -1, 0, 1. Okay, that's pretty easy. Okay, let's go ahead and plot this. What I'm going to do is, just because I don't want to do, it's way too small if I do 1 and 0. So I'm going to actually do, make this like 1 here. And this is 1, and this is -1, and this is -1. It just makes life a little bit easier because it's a bigger picture. Okay, excuse me. All right, so let's go ahead and plot a couple points here. 0, 1. So it's there. And I'm going to label this right away here, math fans. This is my initial point. Okay, and so let's make our way around here. Let's use I need to plot the points first. Sorry. Okay, so here's another point here, another point here, another point here, and hey, it comes back around here again. So actually, this is our initial and our terminal point. Okay, so let's go ahead and graph that then. I use blue. But we start here and we go around, and it's looks like a nice friendly circle. Okay, so that is our initial and terminal point, that top point right there. That's cool. All right, we need to put our direction. So our direction is, of course, this way. It's important to say the direction. And then again, I'd like you guys to even tell me this is initial. If you can put on the graph and on the and even in the chart, initial and terminal point. Okay. It's pretty easy. So it does look like a circle. It's kind of nice. Mine doesn't look like a circle. It looks like a woundy egg or whatever that is, but just stop making fun of me. Okay. Let's convert this. Convert the parametrized curve to a Cartesian equation in standard form. This is a little more challenging, but not a big deal. Okay. So what I'm going to do is, it does look like a circle. So it's interesting. We have x equals sine of t and y equals sine of t. So what I'm going to do is, let me write this out here. X equals sine of t and y equals cosine of t. I think I did say that. Anyway, that's what it is, right? So I'm going to do is I'm going to square these. Okay, square both sides, no big deal. And then I'm going to say, well, what about is x squared plus y squared? So if I add these together, I just set that equal to that, sine squared of t plus cosine squared of t. Ooh, very interesting. Okay, what do you recognize that as? Sine squared plus cosine squared, one of our nice little friendly identities. Okay, you should recognize that as equal to 1. So you have x squared plus y squared equals 1. What? That's our equation. That's like really easy, okay? So pretty mellow, right? That again, it's in terms of x and y. It's in standard form. It is the form of a circle, right? You guys should recognize that with a radius of 1, center at 0, 0. And so that's kind of cool. So it's a circle. So now we have to put our restrictions, and notice it's got x's and y's. So look at our t-chart. Let's go back to our t-chart. What is x between? Do you guys agree? X is between -1 and 1, and y is between -1 and 1. So let's put our restrictions, because you need that. X is between -1 and 1, and y is between -1 and 1. Okay, so once again, math fans, you need to tell me, this is the answer to this. You need to tell me everything about it. You need to tell me the equation and the restrictions, and you're good to go. Okay? All right, last one, which is kind of similar to this, but it's, we'll see. Let's just do the last one here. It's not too long of a video here. Again, graph the following, parametric, indicate direction, the same thing. So we're going to, once again, pick, what is it? Oh, it's between 0 and 3 pi over 2. Okay, so we're going to do 0, pi over 2, pi, and 3 pi over 2. Okay, we'll do all those 4. All right, and then, again, just be careful when you plug it in. Don't mess up sine and cosine of the basic quadrantals, guys. If you do that and you get a crazy looking shape, it's wrong. Okay, so that's like a bad thing. Okay, so I put a 0 in there. Cosine of 0 is 1. That gives me -3. That's back to 0. This is +3, and this is 0. Okay, and then sine of 0 goes to 0 times 8 is 0, and then this becomes 8. And this is 0, and this is -8. Okay, cool. So I can even label this. This is our initial point, and this is our terminal point. Okay, so let's go ahead and plot this. I'm going to make this true to scale here, because it goes up to 8 and to -3 and whatnot. Okay, so we have our initial point is -3, 0, which is right here. And then 0, 8, which is here. And then 3, 0, which is here. And then 0, -8, which is here. Okay, so let's go ahead and graph that baby. It looks like this. And it ends there. So this is our direction. And this is our initial point, and this is our terminal point. Okay, pretty easy. I don't know what this extra little line, random line is here. So we can erase that. Okay, that's good. All right, so that's pretty cool. We got everything here, and of course our last problem, it says convert the parametrized curve to a Cartesian equation in standard form. Okay, so let me write this out here. We have x equals -3 cosine of t, or as you like to say, cost. Okay, and and let's see. Yeah, so let's actually work here. I'll write the other one out here. So y is equal to 8 sine of t. So you can't just square this, because actually if you square this just the way it is, like we did the last one, you end up getting 9 cosine of t, and you can't do 9 cosine squared of t plus 8 sine squared of t. That doesn't equal 1, right? So really you kind of just need to isolate it. So what I'm going to do is I'm going to divide both sides by -3. So that gives me x over -3 equals cosine of t. Hey, all right. And this one divide by 8. So you get y over 8 equals sine of t. All right, cool. Now, if I do that, I can square that, and that. So now I can do the same thing here. It's x over -3 squared plus y over 8 squared equals, I'm just going to put it in order because it's nice, sine squared of t plus cosine squared of t. Sweet! Because this, math fans, oh, it's so nice. Of course, that's equal to 1. So let's go ahead and multiply that out. We get x squared over 9 plus y squared over 64 is equal to 1. Score. That's it. Okay, so what is this, guys? That's kind of weird, 64. What is that? That is an ellipse. Okay, I mean, you can go back and let's look at the graph, right? You see, I mean, it didn't complete the ellipse, but it's definitely the ellipse, but now you got to put your restrictions on there, remember? So go back and look at your chart here. X is between -3 and 3, and y is between -8 and 8. Okay, so x is between -3 and 3, and y is between -8 and 8. And there we go. That's your answer. That is, and it's in standard form. Okay, so that is your ellipse in standard form. Okay, that's pretty sweet. So that's basically, again, we converted it into a rectangular form. And of course, learn how to graph it and everything. And if you look here, I have stuff on the bottom here. It says, tomorrow we're going to convert the Cartesian equations to parametric. So we converted parametric to Cartesian to get in just terms of x and y. And tomorrow we're going to go from just x and y to x, y, and t. Okay, but that is for tomorrow's lesson. So anyway, that's it, math fans. Hopefully this is all good. And like I said, we'll use this again in 2 days. Just a really good application with graphing. It's really, really good. And then we'll use it later on in calculus. All right, that's it, math fans. Have an outstanding day. Adios. Goodbye.